Okay, so we're going to solve this problem, or we're going to solve for the pH. When we take some HNO3 and add it to a solution of potassium hydroxide. So obviously first we'll write our equation. And then we need to think about what we're going to do, right? So solving for scenario A, where we have 24.9 mils of 0.1 molar nitric acid and 25 mils of 0.1 molar KOH. We're going to start by thinking about how much of each we have, right? And obviously the most essential unit would be to convert to moles. And then from here we'll compare. It's a 1-to-1 ratio. So when we look at our number of moles, we realize that, right, nitric acid is limiting, and we're going to have that many moles of KOH remaining. Now we're going to take that number of moles and we're going to divide by our total volume at this point, right, because it's always going to be over our total volume at that point, and that's the molarity of our KOH that remains in solution, right? The KOH that remains in solution. The most important part being the hydroxide. Now, if I want to solve for the pH, it's simply a matter of, right, taking the POH and then subtracting from 14, which gives us 10.30. Now, that puts this part of the problem at just before the equivalence point. Yeah, does that make sense? Right? If we're thinking about a titration, this would be just before the equivalence point. Specifically, 1/10 of a milliliter before the equivalence point. Yeah, make sure that number makes sense. All right, switching up to problem B now, we have 25.1 mils of our 0.1 molar HNO3 with the same scenario of 25 mils of 0.1 molar KOH. So in this case, we're going to get to moles again. And when we do, we realize that in this case, the KOH is limiting, and we actually have excess HNO3. And again, we're going to put it over our total volume at this point in time. And that's going to give us the molarity of, right, the molarity of my nitric acid, or more importantly, the molarity of my hydronium ion, since nitric acid is a strong acid and dissociates completely, which means that the pH calculation is simply negative log of that concentration, which is 3.70. So one thing to notice is that look at the pH spread over 0.2 of a milliliter, yeah, and which indicates that really long rise on a titration curve. So let's talk about a titration curve. Again, pH on the x, mils of my titrant, which in this case is nitric acid on the x. Now let's think about our initial pH. The initial pH reflects just my KOH solution. And if I have 0.1 molar KOH, that means I have 0.1 molar hydroxide, so 10 to the negative 1 molar hydroxide, right? Which means 10 to the negative 1 POH, 10 to the, you know what I mean, 10 to the first POH, and then 13 as my pH. Since this is a strong acid, strong base, we're going to get very little change in pH on the front end till we get to our steep change. And then it's going to have a very long rise for our equivalence point. If we drag it down to the x, the equivalence point is going to happen when the moles of HNO3 equal the moles of KOH. And that's going to happen at 25 milliliters. Since they're equal in concentration, it would require equal volumes, right? And if they weren't equal concentrations, we could do some math to figure out where that would be. And the pH of that place is going to be 7 because all that's left are my conjugate species from HNO3 and KOH. And since they're conjugates of strong species, they have no effect on pH, which means that really we're just reflecting the pH of water. So in terms of where we are, right, 24.9 mils might be right up there at the red dot, and 25.1 mils might be at the green dot. And so again, to just sort of emphasize, right, how much pH change we get in a really tiny volume which again, going back to your guys' titrations, right? That's why 1 drop, huge difference in color. All right, so make sure all of this makes sense. This is a standard titration of 2 strong species, and weak species titrations gets a little bit more thoughtful, so make sure this is good. All right, thank you for listening. Be good, and I'll see you soon. Bye.